Welcome to AP Chemistry. In the previous video, we discussed intermolecular attractions in solid and liquid states. We will now discuss the properties of gases in reference to ideal gas behavior and the ideal gas law. In order to describe gas behavior, we will need the extensive properties of the amount of the substance, measured in moles, and its volume, measured in liters. We will also need the intensive properties of temperature, measured in Kelvin, and pressure, measured in atmospheres. Recall that temperature is a measure of the average kinetic energy of the particles. Pressure is perhaps the new property of this unit, defined as the collective force that a group of gaseous particles will exert on a given area. The first aspect that we consider here is Avogadro's law, which states that equal volumes of gases at the same temperature and pressure will contain equal number of molecules. Therefore, for a given mass of an ideal gas, the volume and amount, or moles, of the gas are directly proportional if the temperature and pressure are constant. In other words, if the temperature and pressure of a gas are constant, the volume is directly proportional to the number of moles. More moles of gas will generate a larger volume of gas. The second aspect we consider is Boyle's law, which states that the absolute pressure exerted by a given mass of an ideal gas is inversely proportional to the volume it occupies, if the temperature and amount of gas remain unchanged within that system. This experimental gas law describes how the pressure of a gas tends to increase as the volume of the container decreases. Therefore, if temperature and amount of gas are held constant, pressure is inversely proportional to the volume. The third aspect we consider here is Charles' law, which states that when the pressure on a certain sample of an ideal gas is held constant, the absolute temperature and the volume will be in direct proportion to each other. This experimental gas law describes how gases tend to expand when heated. Therefore, if pressure and quantity are constant, volume is proportional to temperature. A fourth law, Gay-Lussac's law, established a proportionality between pressure and temperature if volume and quantity are held constant. These four laws can be combined into one form, the ideal gas law, symbolized by PV equals nRT. Now, when we speak of ideal gases, we speak of them in their generalized form, that is, in the complete absence of all possible intermolecular attractions. Real gases never truly exhibit this behavior, but for general circumstances, when temperatures are relatively high and pressures relatively low, the ideal gas law works quite well. Therefore, the various 1 mole samples of gases provided at 0 degrees Celsius and at a pressure of 1 atm will all occupy the same volume of 22.4 liters. Using such values, one can easily calculate the ideal gas law constant, which is closely equal to the more precise value of 0.08206 liters atmosphere per Kelvin mole. Take a moment to consider the following scenarios in relation to the phenomena of pressure, temperature, volume, and mole relationships. Please note the conversions of pressure that are provided below. You will also be required to be familiar with a manometer in order to measure the pressure of gases. Finally, the combined gas law is the form that we will use in problems by which a gas changes state. We will discuss this further in class. The key takeaways for this video are as follows. Pressure, temperature, volume, and quantity of gas are related to each other through the ideal gas law equation, as well as the combined form in which we will take into account the changes that occur in ideal gas. Also, be familiar with how manometers work. Till next time when we consider the mysteries of the absolute, Crip.